is on graphing in vertex form. First thing we want to identify is the A. The A is a positive 1, so that's going to tell us that this graph is going to open up. So the parabola will look like this. It'll have a minimum right there at some point. So we say then it is, the vertex will be the minimum, the lowest point. The A, the A is just 1, so it's not going to be wider, it's not going to be narrower. So it's going to be the same as its parent. So that's all about the A. Then what we want to do is talk about the H and the K like we did yesterday. This number right here is our H. That tells us it's going to move to which direction? The right. That's moving it to the right 4. Then the plus 3, that's our K, that's outside. That's going to move it up 3 units. So that's going to give us our vertex. So find, graph, and label the axis of symmetry and the vertex. So these two kind of go hand in hand from the H and the K. So the vertex is right 4 and up 3. So let's go ahead and graph that. So we're going to go right 4 and up 3. That's going to be our lowest point on the graph. The axis of symmetry runs right through the vertex. So that vertex is an x of 4. So then it's going to be run right through x equals 4. So you write that as an equation, x equals 4. So yesterday we didn't have you graph those lines of symmetry. Today we're asking you to do that now. Okay. The next thing it says is find and graph the y-intercept. So the y-intercept is where it crosses the y-axis. So how we do this is we evaluate the function. We let x equal 0, because this is 0 here. We want to find out what is y. So we substitute that into the function. So g of 0. So 0 minus 4 squared plus 3. And then we simplify this using our orders of operation. We do our grouping first. So we group 0 minus 4. We simplify that. We get negative 4 squared. And then we multiply. Negative 4 times negative 4 is 16. And then plus 3, which is 19. So our ordered pair on our y-intercept is over 0, up 19. So it's way off our graph. Somewhere we're right up in here. So I'm just going to go approximately 0, 19. Now, is it higher than that? Yes. Let's move this little y here out of the way. So that is the ordered pair 0, 19. Then what we can do is we can take that point and reflect it. Imagine you fold your piece of paper along this red line and you can move it to the other side. So what is this distance from here to there? This distance is 4 units, right? 4 units. So what we do is we can reflect it 4 units to the right. So I can go over 8, so here's 8, and then up 19. So 8, 19. So right now I'm just going to do a little sketch of what I have so far. I have the minimum, and then I have a point and a point. So the curve is going to look something like this. Okay. Now I want to find a couple additional points. How I find those additional points is kind of up to you what numbers you want to substitute in. So I'm going to choose a number along the x-axis from 0 to 4 or from 4 to 8. It doesn't matter. So I'm just going to substitute the number 1 in for x. So I would say g of 1. So 1 minus 4 squared plus 3. Do my orders of operation again. 1 minus 4 is negative 3. Square it. Negative 3 times negative 3 is 9. Plus 3 is 12. We now have another ordered pair. That ordered pair is over 1 up 12. So here's 1, and now we're going up 12. Now this is just approximates off my graph, that's fine. Now I can find another point. That red line reflects it. So how far did I go from the red line? This is 3 units. So I'm going to go 3 units this way to now I'm at 7. So now I can find that last point right here at 7, 12. So there's 5 points. The domain of all of our quadratics, what we can substitute in for x, is all real numbers. Every number works from negative infinity to infinity. All real numbers. The range is going to be your y. So I go over to my y. Here's my lowest point. What is that point? That point is over 4 up 3. So what's the lowest y? Here's my x, there's my y. This is the lowest at 3. So it's everything from 3 and higher. So how we do the range is y is greater than or equal to 3. So that's how you can graph a parabola in vertex form by finding all the important pieces.